Students, today we will discuss about neutron rings, the definition of neutron rings and experimental arrangement of neutron rings, and also the interference theory of neutron ring experiment and to determine diameter of neutron rings and the various topics of neutron rings. Now, what is neutron rings? Neutron rings, actually the fringes are circular, which looks like rings produced by interference of light and first observed by neutron, so it is called neutron rings. Neutron rings, why? The fringes are circular, so it is rings, and neutron rings because it is first observed by neutron, so it is neutron rings. And now, neutron rings belongs from which classes of interference? We know the classes of interference, actually two types, two classes. First, division of amplitude, and second, division of wavefront. And the neutron ring belongs from division of amplitude class. Now, experimental arrangement. You see the experimental arrangement of neutron ring experiment. Here is the monochromatic light source. You know the source used for interference must be monochromatic, and then it is convex lens C and P. P is a glass plate which is half reflected and half transmitted and inclined at an angle of 45 degree to the horizontal, and this is plano-convex lens which have large radius of curvature, and this is glass plate, and this is the film where if you not used any liquid, so it is the air film. And neutron rings, these types of rings which is called neutron rings, is produced here for this air film, or if you used water, the water film, and the film of any liquid. Now, the monochromatic source and why S is monochromatic source and why we use the lens. The lens works actually. The divergence rays actually is made parallel by the convex lens. The source S is placed at the focal plane of the lens of the convex lens. Why it is at focal plane? Because the divergence rays only is made parallel if it is placed at focus or focal plane of the lens. Now, the parallel rays incident on the plate, on the glass plate at 45 degree. Now, the incident angle if 45 degree, then reflected angle also 45 degree. So the total is 90 degree, and the rays incident on the plano-convex lens or the glass plate or the film at normally, and then reflected back towards the glass plate, and it is transmitted through the glass plate, and we see by the traveling microscope. Now, why the glass plate is half reflected and half transmitted? If the glass plate is fully reflected like mirror, then all the rays incident there and reflected, all the rays reflected towards the plano-convex lens and the film. Then also it is reflected from there and again reflected. So again and again reflected, but no rays transmitted through the glass plate, and you cannot watch or you cannot observe the neutron ring by the traveling microscope. So it is half reflected and half transmitted. Why the half transmitted? Because the reflected rays here incident here incident at normally at 90 degree and then reflected and transmitted through the P. If it is not transmitted, no rays reach the traveling microscope and you can't watch or observe by the traveling microscope the neutron rings. So it is half reflected and half transmitted. And why it is inclined at 45 degree? You know that actually the rays incident on the glass plate or the film at normally, it is needed for the neutron ring experiment. So that is why it is inclined at an angle 45 degree. Now the rays is incident on the plano-convex lens and which have the radius of curvature is large. Radius of curvature is large. Why the radius of curvature is large? Because the separation between the plano-convex lens and the glass plate is very low. We need that, and there the separation very small. If the separation is very large, then you can't observe very large number of fringes, and the fringes are very closed. That is why the radius of curvature is very large and the width of film is very small. We need that. In the glass plate, only the plain glass plate, and there one can use their air or any type of liquid, and by the experiment actually we can calculate the mu, actually the refractive index of the film. So that is the refractive index of liquid or air. We know that air mu equals to 1 for air, and now the traveling microscope which helps us to observe the produced neutron rings. Now again, what is neutron rings? Ring because the fringes produced by the interference of light are circular, look like rings. And why this is neutrons? Because it is first observed by Newton. And now experimental arrangement, this is here, you can see the picture. This is the S, the source, which is monochromatic light, which must be monochromatic light for interference of light, and this is the lens which is made the observe the lights, diverge lights to parallel lines. And why this is the inclined at 45 degree, and this is only the glass plate which is half reflected and half transmitted and inclined at 45 degree. Why this is 45 degree? Because the parallel rays is reflected towards the plano-convex lens at normally at 90 degree angle. So we inclined the glass plate at 45 degree. Now this glass plate actually have large radius of curvature because we observe large number of neutron rings, and the separation between neutron rings is very large, and if the radius of curvature is very small, then these fringes are very closed, so you can't detect the neutron rings. So that is why the radius of curvature of plano-convex lens is very large. Then this is the glass plate, and the air or the liquid placed at the separation between the plano-convex lens and the glass plate, which works as film, and which is which helps us which is produced the neutron strings. And the traveling microscope which helps us to observe the neutron strings which is formed here. And so this is the experimental arrangement of neutron strings, and I will explain the next. The topics is interference theory of neutron strings experiment, and also how we determine the diameter of neutron strings, also the refractive index of the film, and the radius of the curvature of the plano convex lens. So I will upload the videos discussed about these topics. If you want to understand or learn about the neutron strings in details, please you watch the next videos, and if you like and if you enjoy the videos, please subscribe the channel and share my videos. So thank you for now. Okay, goodbye.